Toby invested £4,500 for 2 years in a savings account. He was paid 4% per annum compound interest. How much did Toby have in his savings account after 2 years? Now the key bit of this question is this idea of compound interest. You all have a familiarity with compound interest because I would imagine you all have a bank account. With a bank account of any kind, you put money in the bank account. If you were to then leave it there, after a certain specified period of time, usually a month or a year, you would get paid some money from the bank. This is interest. Now, interest is a return on your money. Attached to any bank account is a certain percentage, and that percentage is used to calculate the interest. The idea being that, for example, as in this question, at the end of the first year, you get 4% of whatever is in there as a gift, as a bonus given to you. So you start off with the £4,500, the end of the year, 4% of that is then paid to you and put in the bank account. At the end of the following year, you get another 4% of whatever's in there. The end of the following year, another 4%. The end of the following year, another 4%. But the thing that it's important to remember about compound interest is that while you will get the same percentage each time, you will not necessarily get the same amount of money. You'll get the same proportion, the percentage will not change, the value of the interest, but the amount of actual money that gets paid into your account will not always be the same. Think about it. You get 4% at the end of the first year. Well, if there's a different amount at the end of the second year than there was at the end of the first year, you'll get 4% of the new amount, which won't be the same. It might be more, it might be less. It depends what you've done with your money. Same at the end of year 3, you'll get 4% of whatever is in there. If you've suddenly taken all of your money out of your account, you're not getting 4% of very much. We have to be able to work with compound interest, and in fact compound growth and compound decay. The idea of things increasing in value in this kind of way and things decreasing in value in this kind of way. Usually to do with compound interest, interest in a bank account, money going up, or something losing its value over time, its monetary value. We'll have a look at this question to start with. Toby invested £4,500 for 2 years in a savings account. He was paid 4% per annum, that's per year, compound interest. How much did Toby have in his savings account after 2 years? So what we're going to do is we're going to be nice and careful with this. We're going to do this systematically. And we're going to think about 1 year at a time. It is incredibly unlikely that these would be non-calculator questions. They are far more likely to be questions that they can set you with a calculator. We still want to be able to work out the percentages properly. We're still going to write down our working, but you are probably going to have the aid of a calculator with these, just because the numbers start to get a little bit fiddly sometimes. So we're going to start off with year 1. And we start with the £4,500. So there's our 100%, £4,500. Well, we need to get down to 4% of that. So why don't we work out a simple percentage? Why don't we work out 10%? Now, if we have 100% and we want to find 10%, we're going to think back and we're going to divide it by 10. Not because it's 10%, but because 10% make up 100%. So if we divide by 10, we will find that 10% is £450. Okay, so we're a step closer, but really we want to aim for 4%. So why don't we find 1%? If we divide by 10 again, that will give us 1%. So £45. Now, once we've got that 1%, we can use that to find 4%. If we need 4%, we'll just want 4 lots of this. So 4 lots of the 45 is £180. So at the end of that first year, we start off with £4,500, and at the end of the year, end of year 1, we have 4,500, and then we are given the £180 is £4,680. But we weren't interested in what happened after 1 year, we were interested in what happened after 2. So we start year 2. Now, how much do we start with in year 2? We don't start with £4,500 anymore. We start with this value down here, because this value at the end of year 1 carries over to start off year 2. So we're now starting with a 100% of 4,680, a little bit more than we had at the start of year 1. We can go through the same process again. We can find 10%, and then we can use that to find 1%. Well, 10% divided by 10 will give us 468, and then 1% will give us £46.80. We don't want 4%, we don't want 1%, we want 4%. So we can do 4 lots of this. 4 lots of the £46.80, which will give us £187.20. So at the end of the first year, the amount of interest we were given was £180. The end of the second year, the amount of interest we're given is £187.20. They are going to be fairly similar because the percentage hasn't changed, and because it's quite a small percentage, the amount of interest is not going to be the same, but they are going to be similar. If we're getting a number in the same kind of ballpark, we're probably doing okay. So at the end of year 2, which is what we're interested in, we have whatever we started year 2 with, 4,680, plus the £187.20, which will take us to a final answer of £4,867.20. A company bought a van that had a value of £12,000. Each year the value of the van depreciates by 25%. Work out the value of the van at the end of the 3 years. Now this question is actually very similar, although it doesn't mention compound interest. We are still talking about this idea of growth or decay. This word depreciates means it loses value. It means at the end of the first year it loses 25% of its value. At the end of the second year it loses another 25% of that value, and at the end of the third year it loses another 25% of that value. But as the value is decreasing, we're finding 25% of different numbers. For year 2 we'll be finding 25% of whatever its value was at the end of the first year. For year 3 we'll be finding 25% of whatever its value was at the end of the second year. So it's the same kind of idea, but rather than adding interest on, like we did last time, we are taking value away. So we're going to set up, I'm going to split our page into 3. I'm going to do year 1, year 2 and year 3, and I'm going to keep things nice and organised. Year 1, year 2 and year 3. Again, we can use a calculator to help us. So we start the question, we start year 1 with a value of £12,000. That is our 100% starting point. We need to work out 25%. So maybe I'll halve it to find 50, because that'll be easy enough to do, 6,000. And then halve that again to find 25%, 3,000. So at the end of year 1, it goes into year 1 with a value of £12,000. £3,000 of that value disappears, and we're left with a value of £9,000. Now that £9,000 is the value of the van at the beginning of year 2. So we start year 2 with a 100% value of £9,000. We need to find 25% again. So 50% of that, half of that, 4,500. And 25%, half of that again, 2,250. The end of that year, it started the year with £9,000 of value. £2,250 of value disappears, and we're left with an end of year value of £6,750. Now that value at the end of year 2 carries over into the start of year 3. So we begin year 3 with a 100% value of £6,750. We need to find 25% of that, so we could halve that to find 50%, 3,375. And we could halve that again to find 25%, 1,687.50. So at the end of year 3, we went into the year with £6,750 worth of value. £1,687.50's worth of value disappears, and we're left with an end of year value of £5,062.50. Exactly the same kind of question, just decreasing in value rather than increasing. Keywords to look for in these questions so that you know it's one of these type, where the percentage will stay the same but the amount that something is going up by or going down by changes over time. Keywords to look for: compound interest or compound growth, appreciation, depreciation, appreciation meaning something goes up in value, depreciation means something goes down in value, or compound decay. They tend to stick with monetary value for these, the idea of bank accounts or cars losing their worth, but they could ask these same questions with populations, say populations grow or decline in exactly the same way. The more people there are to have babies, for example, the more babies they will then have. But then if there are more babies, they can grow up and have more babies as well. The exception to this kind of question is in this final example. Darren leaves £350 in his building society account for 3 years. The account paid simple interest at a rate of 8% per annum. How much does he have in his account after 3 years? The key word in that question is the word simple. You have specifically been told that this is something called simple interest, not compound interest, not just interest on its own. If it mentions compound interest, it's exactly like the one we did before. If it mentions interest on its own, it's probably going to be compound interest. But the specific reference to simple interest means that this is something different. So what is simple interest then? Well, simple interest finds the interest at the end of the first year, exactly like we did in the previous one. But then, each year after that, that amount of money gets added. We don't recalculate the interest at the end of every year. We calculate the interest at the end of year one and then add that on for all eternity. It is a slightly artificial thing because simple interest doesn't tend to happen very much in real life. Compound interest is better for bank accounts because it's better for you as a bank account owner if you keep putting money in, but it's also better to the banks because if you take money out, they have to pay less interest. Whereas with simple interest, they are paying the same amount of interest whatever you do with that bank account. So if you fill up your bank account and then at the end of the first year, just after they've paid a large amount of interest, you empty that bank account and leave 1p in, they are still paying the same amount of interest every single year. So simple interest doesn't really turn up that much in real life, and it doesn't tend to turn up that much in questions either. They tend to stick with compound interest because it's a bit more realistic. But there is a chance that a simple interest question could come up, and they are actually mathematically slightly easier, or at least slightly less work. So with simple interest questions, we have to work out the value of the interest at the end of the first year. So we start with our 100% of £350. We are aiming for 8%, so we could work out, say, 10%. That would be easy enough to work out. Divide it by 10 to get £35. We could divide by 10 again to get 1%, £3.50. And then we need to work out 8%. Well, there's a couple of different ways we could do that, but what we could do is we could start with a 10% and then we could take off 2 1%. Do a 10%, take away 2 1%, so that'd be £35, take away £3.50, take away £3.50, would leave us with £28. So at the end of the first year, the amount of interest is £28. So, end year 1, 350 plus the 28 gives us £378. End year 2, 378 plus another £28, £406. And then finally, end year 3, 406 plus another £28 will give us a final answer of £434. Again, very much the exception. We would only do this if there is a specific mention of simple interest, mentions of compound interest or interest in general, compound growth, appreciation, depreciation or compound decay are specifically the two previous examples.